In this screencast, I'll demonstrate how to visualize RNA-Seq expression data using Integrated Genome Browser. Notice that I've already loaded a genome and gene models into IGB. To demonstrate loading a BAM file, I'll open a web page on the BioViz web server where I've set up a sample BAM binary alignments file containing data from an Illumina RNA-Seq experiment. To load the BAM file into IGB, I'll just click it to select it and drag it into the IGB display. Notice how now the sample BAM file appears in the load mode table in the data access panel. Next, I'll change the load mode for the BAM file to region in view, and then zoom in on a region, and click Refresh Data to load the data. After a few seconds, all the alignments data that overlap this region will appear in the IGB display. Notice how after I've zoomed in, I can see the sequence bases for individual reads. These represent reads aligned onto the Arabidopsis genome, the reference genome in this case. Blocks connected by lines represent reads that are split across introns. These are spliced alignments. Now, as you can see, there's pretty good agreement between the reads and each other, with a few differences. However, for most purposes, you'll mainly want to see the differences between the reads and the genome, and not necessarily the differences between the reads and each other. So to show just the differences between the reads and the genome, I'll zoom out a bit, and I'll click Load Sequence in View. What happens next is that IGB goes to the server and downloads the genomic sequence for this region in view. IGB then replaces the read sequences with just the differences between the reads and the genomic sequence. Notice how at the top of the display, at the top of the reads track, there's a row of reads that are a slightly darker color than the reads underneath them. This indicates that there are some number of reads that overlap in this region that are being drawn on top of each other instead of in a stack like the reads underneath them. This is because I've configured IGB to limit the number of reads that can be stacked on top of each other within an individual track. Now, if I want to see more reads, I simply right-click on the track label, select the Adjust Max Expand option, and enter a new maximum track height, in this case 15. Now, if there are 15 reads overlapping this area, they'll all appear in the display, and if there are more than that, they'll be drawn in this collapsed row at the top of the track. If I want IGB to display all the reads without collapsing any of them, I right-click again, and I set the max expand setting to 0 for unlimited reads. And as you can see, there's a very large number of reads overlapping this region. Notice how I'm using the vertical zoomer to stretch the display in the vertical dimension. This allows me to see individual reads, even though there are clearly many hundreds of them in this view. Now I'll change the max expand setting back to the original setting of 10, which is the default. Next, I'll show you how you can get an overview of the general read coverage in a region. I right-click on the track label again, and I select the option Make Annotation Depth Graph. I choose the option plus minus because I'd like for all the reads to be summarized in a single graph, regardless of whether they originate from the minus strand or the plus strand. IGBY by default will place the new graph at the top of the display. I'll click drag it closer to the coordinates to make it a little easier to see. Now because this is a graph, I can change its settings using the Graph Adjuster tab. And to start, I'll make it taller, again to make it easier to inspect. I'll add a y-axis. I'll change the graph style to a line graph, and I'll change the color. Now if I zoom out a bit to expose more of the genomic region, and then again click Refresh Data, what happens next is IGBY will retrieve additional reads that overlap the region, and it'll also refresh the appearance of the depth graph to reflect the newly added reads. Now last but not least, I can save the graph by selecting it and clicking Save Selected Graphs. IGBY allows me to save the graph as a wiggle file or a scored interval graph EGR format file. And I can do the same thing with the reads track. I can save the annotations, the track, as a bed file, and then open it up again later.